Hello, fellow mathematicians. I bet you are wondering why I am making you change subtraction to addition. I haven't really been clear about why, but I would love to show you the reason. Okay, so this picture that you're seeing right now are the properties of real numbers, and that's what we've been talking about, and that's what we are going to talk about in this class. So we're going to just look at a few of them because we haven't talked about all of these properties yet. But if we take a look at the commutative property and the associative property, I want us to take special note of that's big, that's all right. Of the only two properties that exist in these properties of real numbers. And that's addition and multiplication. And as I've talked about previously in this class, it's like subtraction and division are just made up to make it easier for us to write. So mathematicians don't have to go the extra mile in writing what's actually happening. Everything can be rewritten as addition and multiplication. And that's the reason we're doing that in this class, is because the properties of real numbers only apply to those two operations. So what are these? Well, the commutative property is changing the order of the number will not change the result. And that only is true for addition and multiplication. But we're going to just focus on addition today. So you're like, but what does that even mean? Why does it only work for addition? Well, let's look at an example here. I'm going to make this bigger. Oop, not that big. All right, so let's say we have 3 plus 8. So if I do 3 plus 8, I'm here on the number line. I start at 3. I'm adding 8, so I'm moving 8 units to the right. 1, 2, 3, 4, 5, 6, 7, 8. I get 11. Cool. The commutative property of addition tells me that if I rearrange the order of the numbers, I'm going to get the same result. So let's see. So if I take 8 plus 3, I'm going to start at positive 8, and if I add 3, I'm moving 3 units to the right, and I go 1, 2, 3, and I wind up at 11 again. So you would think that this would work for subtraction, right? Well, let's see. Let's use these same numbers. I'm going to clear my number line. Let's go 3, or let's start with 8 minus 3. So 8 minus 3 means that we're starting at 8 and we're subtracting 3. So we're going to the left 3 units. I go 1, 2, 3, and I'm at 5. The commutative property tells me that if I rearrange the order of the numbers, I'm going to get the same result. So 3 minus 8. So that means I'm going to start at 3, and I'm subtracting 8, so I'm going 8 units to the left. So 1, 2, 3, 4, 5, 6, 7, 8. My result is negative 5. Well, positive 5 and negative 5 do not equal each other. Trust me, I would much rather have positive $5 than owe someone $5, because that's what a negative $5 would be, owing someone some money. But let's take a look at these same numbers again. I'm going to clear my number line. So if I have 8 minus 3, and as we've talked about in this class, anytime that we see that subtraction sign, we automatically need to think add the opposite. So we're going to rearrange this or rewrite it and take 8 plus the opposite of 3, which would be negative 3. So let me do this problem on the number line. Start at 8, and I'm adding a -3, which means I'm going to the left 3. 1, 2, 3. All right, we get to 5, just like we did before. But now let me rearrange these numbers. Let's see if the commutative property works. So I have -3 plus 8. I'm rearranging the numbers around my plus sign. Let's do this on the number line. I'm starting at -3. I'm adding 8, which means I'm moving 8 units to the right. 1, 2, 3, 4, 5, 6, 7, 8. OMG. This is why we are rewriting subtraction problems. Because if we rewrite subtraction problems to addition problems, the commutative property works for us. And it's a lot easier to rearrange numbers around plus signs. We don't have to worry about other things. Because sometimes we need to just move numbers around to make it easier for us. But this is the reasoning behind rewriting. Because I have students who think that these problems are the same without ever answering them. And they're not. And I noticed on some of your guys' work that you turned in from our first assignment where we rewrote, well, our second assignment where we rewrote subtraction problems as addition problems, and this is what you essentially did. It's not correct. Or I saw, just because this was the very first problem, we're going to talk about it. The very first problem on that worksheet was 2 minus 1. I saw about half get it correct and half get it wrong. So what I saw was a lot of people just did that. Well, let's dive into this. Let's see what's going on here. So this is the original problem. So let's do that on the number line. We start at +2 and we subtract 1. So that means we're going 1 unit to the left. So our answer should be 1. Well, if I do this on a number line, I start at +2, I add 1, I move 1 unit to the right. Those are not the same. When we rewrite problems, we're not creating new problems. We're creating equivalent problems. So see here, we created a problem that gave us the same answer. We're not creating something new. We're simply rearranging our original problem to make it equal to itself. So we're rewriting it. We're not creating anything new. So that first problem from the worksheet, to rewrite it properly, should have been 2 plus a -1. Because remember, it's that negative sign plus the opposite of that number. And let's do that on number line. We start at +2. We add a -1, which means we go to the left, and we're still at 1. So notice that these two problems are equivalent to each other. And that's what we're doing. We're creating equivalent equations. We're not creating new ones. I hope this answers some questions that maybe you're having. I hope this clears up some things. And happy mathing!